Okay, so we are going to look at dilations today. This is chapter 6.8. Here's our first set of key concepts. Go ahead and get these copied into your notes. Draw these puzzle pieces as best you can, but just get the idea of what they look like. It doesn't have to be perfect. And then replay me when you're ready for the explanation. Okay, so we're going to look here. Translations and reflections are two transformations that change the position of an object. Now, a dilation is a transformation that enlarges or reduces a figure by a scale factor. Okay, so let's look here at a translation. All right, what I've done here is I have this puzzle piece here, and I have just slid the puzzle piece up to this position here. Now, if you look at your desk and your piece of paper on your desk and you slide that piece of paper across your desk, you have moved the position, but you have not moved the shape, or you have not changed the shape of your piece of paper. So that is a translation. You're just simply sliding it along. Now, reflection is you're keeping the same shape, but all you're doing is you're reflecting it over this line of symmetry. So let's say you have your piece of paper and you flip it to the back. And so your holes were on the left side and now they're on the right. So you've reflected that piece of paper. And now what we're going to talk about today is dilation. So you look at this puzzle piece here. We've got a big puzzle piece, and we have shrunk it down to this little guy here. And if you remember from similar figure lesson last chapter, we were shrinking and enlarging. We had all those shapes that were kind of like mini-me's or enlarged me's of the shapes. That's what a dilation is. We're going to be creating those, creating similar figures. So here's our explanation. Whoop. When the center of a dilation is the origin, you can find the coordinates of the image by multiplying each coordinate of the figure by the scale factor. Use the notation xy, so that's the point, and I'm going to multiply k, which is the scale factor, to the x and to the y to describe the dilation. Okay, a couple more key concepts, so get these copied in, and then we'll explain it when you're ready. So a dilation with a scale factor of k will be if it is greater than 1. So if my k is going to be greater than 1, then I'm going to enlarge my shape. My shape is going to get bigger. Now if k is greater than 0 and less than 1, so it's going to be, let's say, a fraction, maybe. This is going to reduce the shape, so it's going to get smaller. We're going to get a little mini-me. And if it is equal to 1, then we're going to have the exact same figure. Whoops. Okay, here's the first example. So we've got a figure has vertices J24, K26, M86, and N82. It asks us to graph the figure and the image of the polygon after a dilation with a scale factor of 1/2. Okay, so first of all, I'm going to just graph that figure. So I've got J at 24. I've got K at 26. I've got M at 8,6. 8,6. And that's M. And I've got N at 8,2. Connect the dots here. And this is my figure. JKMN. All right. So now I'm going to come over here and I'm going to make a dilation with a factor of 1/2. So I've got the point J, 24, the point K, 26, the point M at 8,6, the point N at 8,2. Okay, so now I am going to change each of these to have a scale factor of 1/2. Well, what does that mean? Remember, I've got to multiply each x and y by the scale factor, and this time it's 1/2. So here, J prime, it's just a J with a little apostrophe, is 1/2 times 2, 1/2 times 4. Now this will, the new J prime, will be at the point 1/2 times 2 is at 1. And 1/2 times 2 times 4 is 2. So that's j prime. Now let's look at k prime. I'm going to multiply 1/2 times 2, 1/2 times 6. K prime is 1, 3. Now we'll look at m. M prime is 1/2 times 8, 1/2 times 6. And that will be m prime is at 4, 3. N prime will be at 1/2, 8, 1/2 times 2. So my new n prime will be 4, 1. So now I'm going to graph my new coordinates, and they are right here. My new dilation. So j prime is going to be at 1, 2, j prime. K is going to be at 1, 3, k prime. M prime is going to be at 4, 3. And n prime is at 4, 1. Now, if you remember from our key concepts from before, we said that these were going to be the exact same shapes, but just a little bit smaller because this is a 1/2. And I said if it was greater than 0 and less than 1, that means a fraction, that our original size is going to reduce into a smaller size. So that's where we got that. All right, you try this one. When you're ready for the answer, go ahead and replay me. So a figure has vertices r, -3, 6, s, 3, 12, and t, 3, 3. Graph the figure and the image of the figure after dilation with a scale factor of 1/3. So let's let's first of all plot this figure. So we've got -3, 6, and then we've got 3, 12, and 3, 3. Oops, this is R, this is S, and this is T. All right, and then we want to connect our dots. Try and make them as straight as possible. Use a ruler. Okay, that's our figure. And we start off with R at -3, 6, S, 3, 12, and T, 3, 3. We multiply the X and the Y, each of them by 1/3. And for time's sake, I'm just going to do the work in my head. If you'd like to write out, I'll do the first one. Multiplying each of them by 1/3. You are free to do that. If you'd like to go straight into what R prime is, as 1/3 times -3 is -1. 1/3 times 6 is 2. Okay, so that's R prime. And then we can go into S prime. 1/3 times 3 is 1. And 1/3 times 12 is 4. T prime is 1/3 times 3 is 1. And 1/3 times 3 is 1. Okay, so let me highlight these so we can see them easier. Okay, so I'm going to plot these new points on my graph. So I'll change colors. We have our new R at -1, 2, R prime. S prime is at 1, 4, S prime. And T prime is at 1, 1. And this is a little mini-me figure. And shouldn't that be a smaller figure of the original shape? Because what is my scale factor? My scale factor is a fraction, so I know I'm going to reduce that shape. Okay, now these are multiple choice. And this is something that you might see on like standardized testing. So it says a triangle has vertices A, 1, 2, -2, B, 0, 2, and C, -2, -1. Find the coordinates of the triangle after a dilation with a scale factor of 2. And then I put this little thing on the side. It says to dilate, everyday use says to expand or widen, and the math use says to enlarge or reduce by a scale factor. Okay, just a little FYI for you guys. Okay, so how do I solve this problem? So it's asking us what would be the new coordinates if I have a scale factor of 2. So I would plot A, 1, -2, B, 0, 2, and C, -2, -1. And I want a scale factor of 2. So my new A prime would be multiplying 2 to both 1 and -2. So I would have my A prime as 2, -4. My B prime would be at 0, 4, and my C prime would be at -4, -2. So now which ones of these, A, B, C, or D, is going to be matching my new coordinate points? Well, if we look here, C matches every single one of these. So my answer for this one is C. Okay, you try this one as best you can. Replay me when you're ready for the answer. Okay, so we have X, Y, Z. X is at -3, 6. Y is at 3, 0. And Z is at 3, 3. My X prime would be at -9, 18. My Y prime would be at 9, 0. And my Z prime would be at 9, 9. And I got those by multiplying each your X and your Y by the scale factor of 3. And so the one that matches these new coordinate points would be J. So my answer would be J. Okay, I'll do this one. This is a drawing of a school mascot is to be increased as shown at the right, so it can be painted on the gymnasium doors. What is the scale factor of the dilation? Okay, so here, let's look at the picture and kind of dissect it. Here's a picture of the school mascot, and it's obviously pretty tiny. They want to blow up the picture, not like with explosives, but they want to expand the picture so that it can be big enough to be painted on the gym doors. And so they're going to want to increase it, dilate it, and so it's big. So let's look at this small guy. We'll call him Small, the small mascot. His coordinate points are at 1, 2, and 3, 2. And our big mascot, his coordinate points are at 3, 6, and 9, 6. Now let's look here. If I go from small to big, what do I need to multiply by this X to get to this 3? Okay, if you can't see it there, what would I multiply to get from this 2 to get to this 6? Still can't see it? Let's try this coordinate. What would I multiply by to get from this 3 to get to this 9? Or this 2 to get to this 6? Well, if you saw the pattern, each of these you're going to multiply by 3. So what is my scale factor? My scale factor is 3. So in order to get from my small mascot to my big mascot, I've got to multiply each one of these coordinates by 3 in order to get that enlarged picture. All right, you try this one. When you're ready for the answer, go ahead and replay me. It says Megan wants to reduce an 8 by 10 inch photo to a 2 by 2.5 inch photo. What is the scale factor of the dilation? Okay, so I've got this photo here. Let me get those in my face. Of a 10 by 8, or 8 by 10. And then we've got this other one over here, a little smiley face, of a 2 and 2.5. And then I want to know how I got from this big guy to this little guy. So we'll start off with big to small. How do I get there? So my big goes from 10.8, and my small is at 2.5, 2. Now, how did I get from 10 to 2.5? Or how did I get from 8 to 2? And remember, at the very, very beginning, the scale factor was being multiplied. So I need to multiply something to 10 to get to 2.5, or something to 8 to get to 2. And remember, you can use fractions in this. So how did I get from 10 to 2.5 and 8 to 2? Well, I would be multiplying by 1/4. Okay. If you think about it by dividing by 4 in order to get 2, the same thing as division by 4 is multiplying by 1/2. That's the same thing. Okay. All right. So my scale factor is 1/4. Okay, right, remember, because my picture is big and I'm shrinking it, that means I have to have a fraction as my scale factor. When it starts out small and goes to big, I have a positive, a whole number greater than 1 as my scale factor. Okay, here's your extra practice. Go ahead and try these as best you can, and we will go over them the next time we see each other.